All right, so we're on to 6.5, factoring and solving equations using factoring for our first part. So we're going to look at, this is kind of what we've been headed towards. Being able to factor is just a way to help us solve different kinds of equations. So being able to break things down into factors helps us find solutions to equations. So that's what we want to talk about today. How does that work? And we're going to use something called the zero product or zero factor property. It sounds super fancy and everything, this whole like zero factor, zero product property. But basically it means this. If you take two numbers, so a number and then times another number, and your answer is 0, in order for that to happen, one of these numbers has to be equal to 0, right? There's no way to multiply two things together and get 0 for your answer without one of the two things being 0. So that's what we're going to be using to help us with these more complicated algebraic factors. Take a look at this first equation here, for example. You have two things that are multiplied together. So here's factor number 1, here's factor number 2 multiplied, right? And it's equal to 0. What that means is either the 8x plus 3 is equal to 0, or the 2x plus 1 is equal to 0. So we have to figure out what makes each of those equal to 0 to find out what values of x would make that statement true. So we just have to solve each of those statements. So we set each factor equal to 0 and solve each one. So for the first one, go ahead and just do your solving here. You can pause the video and do that. We're going to subtract the 3 first, then divide by 8. So we get x equals negative 3/8. So they do not have to be whole numbers, remember. And then the second one, we're going to subtract 1 first, and then divide by 2. So x equals negative 1/2. So what we're looking at, what we're thinking about, are the places where this function would be equal to 0. So those are your two x values. It's the same thing as saying, hey, what are your x-intercepts? Or it's where this graph crosses the x-axis. So these are the same as finding x-intercepts, or looking for what we call the zeros of the function, like where it crosses the x-axis. So when the function is equal to 0, that's what we're looking at. So if we multiply these together, we get a degree 2 equation. It's a parabola, and this parabola would cross the x-axis at those two locations. So the zero product or zero factor property just helps us find those two numbers. So set each factor equal to 0 and solve. So if it's already factored for you, life is great. So here we have another one. Again, make sure it's equal to 0 for sure. Set each of these equal to 0 and solve. So go ahead and pause the video and see if you can do that. Set each of these equal to 0, each of these two factors, and we're going to solve for x. What makes each of those true? Go ahead and pause and solve. And so we come up with, looks like x equals 3/2, so 3 divided by 2, or x equals negative 6. So those would be our two solutions. So x equals negative 6 or x equals 3/2 are the two places where this graph would cross the x-axis. You could also say 1.5. You could say 1.5. If it's a fraction like that, we can write it as improper mixed or as a decimal. So the zero product property is what we're looking for. Set the two factors equal to 0 and solve. These were factored for you, which is great, but they're not always factored for you. So sometimes we have to do our factoring first. Another thing to keep in mind, they have to be equal to 0, because the zero factor property doesn't work if they're not equal to 0. So we got to make sure that they are. So we might need to move some terms around. And then we can go ahead and set our factors equal to 0 and solve. So take a look at letter A here. Right away, I hope you're noticing something that's different. First of all, there's no parentheses, so they haven't for sure factored it for you. But do you see what it's equal to? 4. That's not going to fly. It has to be equal to 0. So the very first thing we need to do is move all our terms to one side. So I'm going to go ahead and subtract the 4 once on each side. Write your terms always in descending order, so the highest degree term first. So I'm going to put that -4 at the end. There's no like term with it. If there were, you could combine it, but there isn't. Okay, so now our quest is we need to try to see if we can factor this so we can set those factors equal to 0 and solve. First thing I checked for is a GCF. There isn't one, so I didn't have to worry about that. That's why I went right to two binomials. All right, remember this comes from the product of the first, the last, and the middle is the outsides plus the insides. So what can you multiply to get a 3x squared? The only choice is a 3x times an x. What multiplies to give you a 4? What are your choices here? Well, you could do 2 times 2 or 4 times 1. Can you pause the video and do some guessing and checking here and see if you can come up with your factors? Remember, it's a negative, so that means you're going to have one of each sign. So see if you can find the one that when you multiply your outsides plus your insides together and you add up those two terms, you'll get a -1 in the middle, -1x. All right, so pause the video, see if you can try that. So to get a 4, I think what we want is actually the 4 and the 1, and I think I want the 4 here and the 1 there. I want to have a difference of 1, so 4 and 3 have a difference of 1, so I think that looks pretty good. I want it to be a negative 1, so I want the 4 to be the thing that's a negative, and the 3 to be the positive. So let's check our outsides plus our insides. So outsides, I would get a 3x. Um, and insides I get a negative 4x, and together that adds to, there we go, my negative 1x. So that looks like the right pairs that I need. Just be careful, you have to maybe do some guessing and checking, but we get those two factors. Okay, now we're ready to use that zero factor property. Set each of your factors equal to 0 and solve. So either the x plus 1 has to be equal to 0 or the 3x minus 4 does, and then just solve for x. That part shouldn't be too hard, so go ahead and solve for x. So x equals negative 1 for that one, just subtract. This one we get 3x equals, what, add 4, so positive 4, x equals 4/3. And again, you could do 1 and 1/3, or you could say 1.3, but make sure you say repeating. You don't want to just round, you want exact answers. So any of those ways is fine. So it's x is 4/3 and x is negative 1. A little bit harder though when you have to factor yourself first, right? Get all those terms on one side so you can use that zero product property. All right, let's try another one. Okay, so is it already equal to 0? Check. Good to go. It's equal to 0. So next factor. All right, first thing, check for GCF. Do you have any common factor you can pull out of a 16, a 24, and a 9? They're not all even, so can't pull out a 2. 24 has a factor of 3, and so does 9, but 16 doesn't. I think we're kind of stuck. So we're going to go right to 2 binomials. There's nothing I can do to pull out a GCF. All right, so let's see if we can factor. Remember the perfect square trinomials we were talking about before, how we look for things that are, when they're trinomials like this, things that are perfect squares? Is 16 a perfect square? Yep, that's 4 squared. Is 9 a perfect square? Yep, that's 3 squared. My gut's kind of telling me this might be one of those perfect square trinomials. So 16 is 4m, so m squared times 4m. How do we get a 9? Remember, that's your first. Here's your last. 9 would be 3 times 3. And remember, it's positive, which means the signs are the same. The middle term is positive, which means they're both positive. Let's double check, see if that works. Just because they were perfect squares kind of gives me a feeling that might work. 4 times 3 is 12m, and 3 times 4, another 12m. When I add those up, oh, there's my magic number, 24m. So I know that these are the right binomials. Now, if you remember about these perfect square binomials, or trinomials that factor into binomials, what do you notice about the two binomials? They're exactly the same. So when you're going to set these equal to 0 now, you actually get the same answer for both of them. So you don't need to solve it twice. You can just do one of them. And let's go ahead and solve. So we'd subtract 3. So 4m equals negative 3. And then m equals negative 3/4. So you divide by 4. So this one actually only has one unique solution, different solution, because both of the binomials were the same. I want you to think about how that happens in a degree 2. So these are parabolas, remember. And remember, when it equals 0, those are the x-intercepts. So think about how that could be for a parabola. How could only one point touch the x-axis? Well, how about if it's just the vertex, right? So this one is saying it's only touching only at the vertex, so at negative 3/4. So it only has one solution. Whereas the last one we did, this parabola would be one that's crossing at 1 1/3, so like here, and also at negative 1. So it's one of these kind of graphs where the parabola crosses twice. So if you only have one solution, that means it's just a single vertex point that's on there. If you have two unique solutions, that means it must have crossed in two places. The other option for parabolas is if they don't cross at all. So like one of these, like the parabola is opening up and the vertex is above. That situation, you wouldn't be able to solve this at all. You wouldn't be able to get a solution. So this zero product property is really a great way for us to know not only about just the x-intercepts, but about what's happening on the whole graph. All right, let's try one last one. Dealing with some of the other things again we did earlier in the chapter. So p squared plus 12p equals 0. Is it already equal to 0? Yep, check. That's good to go. So we want to try to factor it. Now remember, factoring a lot of times is two binomials, but remember how we always check for a GCF. So we're always going to try to look for a GCF. Is there a GCF in these two? Well, yeah, you can pull out the p. So what would that leave inside? So p times what would give you p squared? So that would be a p. plus p times what? Give you 12p. So plus 12. If you factor out a GCF, in this case it's a p, now we have still two factors. I know it's weird, but this is a factor. I guess technically you could write it p minus 0 if you wanted to. It's a factor though. That's one of the factors. And then the other one is the p plus 12. So I set each of them equal to 0 and I solve. Now this is actually supposed to be easier, but it's harder for people sometimes. What makes this first term 0? 0. If you plug in a 0 there, you're gonna get 0 for the whole thing. Think about that, plugging in 0 into both. Yeah, you're gonna get a 0 output. So it's not really anything to solve. In this one, you just have to subtract the 12. So if we either use a negative 12 or a 0, we're going to have the zeros of this polynomial. So this parabola, if you think about it, it's crossing at negative 12 and it's crossing at 0. So you have a parabola that's crossing twice. So 0 can very well be a solution to one of your two factors. I know it looks kind of goofy, but always pull that GCF out first. Now, if the GCF that you pull out is just a number, so say you pull out like a 2 and then you have whatever, that does not contribute anything to solutions. There's no way that this can be anything but a 2. You don't set it equal to 0. There's no variable there, right? So GCFs that are variable terms are the ones that are actually going to contribute something to the factors. If it's just a coefficient, just a constant, yeah, that doesn't have a letter with it. We don't have to worry about that. We want to pull it out so we can factor what's left, but we don't worry about it for solutions because it's not a variable. It can't have a solution. It never changes. All right, so zero product property, great way to be able to solve, to find out these quadratic degree 2 equations, and actually we'll find even higher as well. Factor, set each of your factors equal to 0 and solve. Be sure again though that your terms are all on one side. Make sure it's equal to 0 first.